We've been working with exponents now since chapter 1. What we want to do is extend the concept of exponents and add some properties of exponents to our work. Over here I've got the instruction simplify, and I have 1/2 to the 4th power. Remember, the base is 1/2, the exponent is 4, and the 4 tells us to use the base as a factor 4 times. So it's repeated multiplication, 1/2 times 1/2 times 1/2 and times 1/2 again. There's my 4 factors of 1/2. Multiplying fractions, I multiply across the top and I have 1. Multiply across the bottom, 2 times 2 is 4, times 2 is 8, times 2 is 16. So that comes out to be 1/16. So 1/2 to the 4th power, 1/16, and that's just using our definition of what an integer exponent means. Let's look at our next problem. X to the 4th times x to the 5th. I could write out 4 factors of x here, 5 factors of x here, and then simplify. But I have a property of exponents that tells me when I multiply with the same base, I take that base and raise it to the sum of those powers. So I add exponents when I multiply with the same base. So it has to be exactly the same base in both places, and it has to be multiplication. So this then will simplify to x to the 9th power. So that's our property 1 for exponents. Multiply with the same base, we add exponents. Our next problem, I have x to the 2nd power, all of that raised to the 5th power. So I have a power raised to another power. My properties of exponents tell me that that's x to the 2nd, or x to the 2 times 5. I multiply exponents when I have a power raised to a power. So when I multiply 2 times 5, I get 10. So that simplifies to the x to the 10th. And I can think of this as 5 factors of x squared. Each of those is 2 factors of x, so I'd have 2, 2, 2, 2, 2, 2, 5 different times. That's going to give me a total of 10 factors of x. So these properties of exponents are really a shortcut. You just have to memorize the form of them right here so you know when to multiply and when to add. Let's look at our next problem. 4xyz in parentheses raised to the 3rd power. I have a property of exponents that tell me that exponents distribute over multiplication. So this is 4 to the 3rd times x to the 3rd times y to the 3rd times z to the 3rd. That's what it means to have parentheses with an exponent of 3 outside and all multiplication inside. 4 to the 3rd power, 4 times 4 is 16, times 4 again, I get 64. And I'll just write it as x cubed, y cubed, z cubed. So that's an alternate form of this expression right here when I remove the parentheses and distribute that 3 over all of those factors inside. Here's another problem I want to simplify. I'll have to use the commutative and associative properties. I'm going to rewrite this as 3 times 2 times 5 times x squared times x to the 3rd times x to the 4th, where I take my numbers in front here, these coefficients, and write them together, and then x squared, x cubed, and x to the 4th, writing those together. That is the commutative property and associative property for multiplication. Now I'll multiply. 3 times 2 is 6, times 5 is 30. X to the 2 plus 3 plus 4, because it's multiplication with the same base. So I'm going to add exponents. 2 and 3 is 5, and 4 is 9. So I end up with 30x to the 9th power. So there's some of the properties of exponents, at least our first 3 properties of exponents. Let's turn our attention now to scientific notation. I want to write this number right here in scientific notation. Scientific notation always starts with a number between 1 and 10. Here's my decimal point right here. It's not written, but that's where I assume it is. I need it to be right here so that I have a number between 1 and 10. So I'm going to write this as 4.32. There's my decimal point, times a power of 10 that will make this number equal to this number. So here's where my decimal point was. I moved it over 1, 2, 3, 4 places. So I'm going to multiply by 10 to the 4th. 10 to the 4th is 10,000 times 4.32 will give me 43,200. So this number is written in expanded form. I change it to scientific notation this way. I've just changed the form of the number. I haven't changed its value. Let's go in the other direction. How about if I take this number that's written in scientific notation and rewrite it in standard form? It's going to be 2.49 times 10 to the 3rd is 1,000. When I multiply 1,000 times this number, that's going to move the decimal point over 3 places. I'll have 2, 4, 9, 0, so the decimal point goes over 1, 2, 3 places. So 2,490 is the expanded form of this number right here written in scientific notation. So that's our first work with exponents and the properties of exponents.